Hello everyone, and welcome to another episode of State of the Raven. And I'm sorry for the slight delay. We had a small internet connection problem in the office. Everything is okay now and we can start. The previous week I tried to give you a demo of SQL replication or replicating from RavenDB to a SQL Server. And it turned out that we had some bugs and things that made it harder for us to work with SQL replication, and the demo, let me put it, blew up horribly in our face. So what I want to do today, I want to retry the exact same demo, and let's see, I'm going to start the very latest version of RavenDB. And this is now going to get started. We open the database and let's create the SQL. Create a SQL replication bundle, and we're almost ready. The first thing that we need to do is let's create a sample document. And I think that should do it. And okay, so we have a pretty nice sample document. Now let's go to our relational database and look what we have. We have the users table. And it's not really neat. You know what? Let's start from scratch. I'm going to create a new table, a user ID and voucher, and let me just, okay, and this would be the primary key, and let's call this name and voucher, email. Okay, so this is the users table. Let's create another table, and that's good. So now we have the fonts and the users table, and I actually want to replicate both of them from RavenDB to SQL. Let's see how we can do that. Users, using to SQL Server, we're going to replicate users and fonts, data source, a SQL Express, and initial catalog, Raven.test, and integrated security equal SSPI. Now, let's start from the simple thing. I want to replicate to the users table that has the user ID primary column, and right now I'm going to specify the mapping. And email. So far so good, and really easy for us to work with, right? We have defined this in here, and now I'm going to go here and look if we actually managed to get it in here. And yes, we are actually able to store the data inside the database. And that, I think, is really, really awesome. Mostly because the last time I did this demo, thing did not work. But this is still a fairly simple thing to do. Let's try to do something more interesting. And again, if you hear any whining in the background, that would be my dog that really doesn't like it that I'm actually going to use a relational database. I think she's allergic to that. and font is this dot fonts I. Okay, so now let's see. And let me just kill everything, and here we go. And here we don't actually have anything. That is because we edit something, and edits in here are reflected only for new items. So let's force this to happen to new items as well. And we do that by going here and removing this entry. Once we have done that, you can see that we actually have all of the data replicated. Now, let me show you something even more interesting. Let's see what happens when there are errors. And in this case, email is null. And we can see that this did not get replicated. I can go to the logs and select the errors. I can see here is the error. Okay? We try to execute this statement, but we cannot insert a null into the email column. We're going to fix that. Yes. And ta-dam, ta-dam. And you will allow me just a few seconds to bask in the knowledge that it actually worked when I actually wanted to demo that. And let's see some questions that people have. Okay, so Matt is asking, what happens if the string length exceeds the SQL column size? And the answer is that, as you have seen, this will actually give an error. So let me show you what's going on. Let's create a very long property. And we were able to see that we had an error because of this. String or binary data would be truncated. If we can't put data into SQL Server, we cannot put the data into SQL Server. Now, we could, remember, we have a script here. We could change things around. So, substring to 40, something like this. Now, when I'm doing that, I'm truncating the data manually. I really hope that this is the way to do that. And let's see. As you can see, the data has been truncated. So I actually have the ability to modify the data in any way, shape, or form. For example, I could, basically guys, I can write anything in here that I can do using JavaScript. So any sort of modification that you want. You can see here that we took a relatively complex object and we pulled it into two separate tables. I can do modification, I can do any sort of things that you could possibly do. Behind the scene, we batch all of those updates. We generate the optimal SQL, blah, 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 and we just make sure that things work for you. Questions about this topic? None. No, there are. Yes. So Daniel Marbach is asking, do you plan to support versioning on the scripts? Can you explain what you mean? What do you mean versioning on the script? So I just don't know. I would really, okay. Okay, so if someone changes the script and you want the old values to be saved. No, this is not something that we plan to do, mostly because that's something that is the responsibility of the user who actually edit that. Remember, everything that we do, or pretty much everything, is just documents. So, you know, let's do something just as interesting. I'm going to activate the periodic backup routine, and I'm going to tell it to go to /work/SQL demo. And let's see what's going on. And you can see that we have some backups in here. And if I'm going here and changing this to remove this guy, then in 1 minute, I would actually have the value out. Now, we actually got questions about those value in the mailing list, those files. So let me show you where they are. This is just a gzip archive, and it contains JSON. And you can see all of the values that we have, including, by the way, those guys. So here is the, here you go. So here is the configuration. When this changes, date modified, here we go. So when this changes, we have no, that's no change. Okay, so we don't see that. Okay, so it's somewhere around those files, and this is the basic. This is how I would actually worry about versioning in that way. And if you want something like Git or CSV or those sort of things, this is where you use Git or CSV. Please don't use CSV, but just use Git to store those. Again, this is just documents, and you can store them wherever you want and however you like. And the basic idea in those sort of things is basically to give you some means of operating within the scope of within your operational scope. So that's it, guys. That's the things that I wanted to demo. I wanted to demo the SQL application and show you that it actually works now. And I wanted to demo periodic backups. So from here on out, this is your show. You get to tell me what we're going to talk about. And Remo asked, can you define the SQL application in C# similar to the way you define indexes? The answer is no. We got several questions about that in the mailing list, and the answer is that as soon as someone wants to build a link provider to JavaScript and send us a pull request for that, I would be happy to accept it. But this is an operational feature. This is something that you would have in maybe once or twice in the entire system. This is not like indexes where you have tremendous number of them. More questions? Yay! By the way, guys, feel free to stream the questions even while I'm answering on an existing one. So Matt Johnson is asking, can you demo periodic backup a little more? I saw them in there, but an end-to-end would be nice. How to set them up, where to go, how often it runs, etc. Okay, so this periodic backup is going to run every minute, and it's going to replicate to this path. If I wanted to restore from this path, I would do something like this. CDP, no. /debug/ okay, so I would use the smuggler, and yes, I think that I have a revenue engine in here. And guys, I'm actually very sorry. I wasn't supposed to do this from home. But again, the internet cut out at the office, and it was hard to do this. So smuggler in HTTP/localhost 8080 and c/work/SQL demo incremental. 1 second. Let me just kill this thing. Incremental database SQL 2. Okay, now you can see that we update all of those values. I'm going to go here and we have SQL 2. And you can see that we actually restored everything to its proper point in time. The actual command that we executed was this thing. Okay, so smuggle into this URL from this directory. We are importing an incremental backup and push this into this database. That's the way to do so. Now, with incremental backups, we also have the ability to do things like this. We can do a periodic backup to Glacier or to S3 and those sort of things. When we do those sort of things, what happens is that it's your responsibility to actually get the data from S3 or Glacier or whatever, drop them into a directory on the file system, and then just execute this command and everything will work for you. Okay, a question from Daniel Marbach. Would you recommend also store indexes, etc. in the VCS? So by actually copy-pasting changes into the VCS? Absolutely not. There is a really nice way to work with indexes and change control, and this is the abstract task creation index. This is what it's for. So your index definition will get stored along with your actual code. They are versioned together, they are deployed together. The entire thing just works for you. You don't have to worry about, oh, did I deploy the right versions or not? Put the indexes definitions inside your code. This is how it's supposed to be working. Dan Leibster, out of technical curiosity, what are you using under the cover such replication is defined using JavaScript? Dan, I assume that you're talking about SQL replication, and we're using Jint, the JavaScript interpreter. We use a somewhat modified version of this one. If you really care, the code for modification is in our repository. The reason that we use Jint rather than V8 or Jurassic or one of the other ones is that this is actually interpreted. That means that debugging something like that is much, much easier. Adding our own customizations, adding our own limits, those sort of things make things much, much simpler all around. So that's basically what we're using Jint. And the reason that we are using JavaScript in the first place is that this is something that you tend to be do once in a while. And again, this is an operational task. This is not something that you would typically expect a developer involvement in it. This is the guy that, okay, I need to write some reports, I need to do those sort of things. So we wanted to make it really, really easy to do those sort of things. And JavaScript was a rich language that has very low threshold. If you think about it, the default approach that we use is really just give us the values in this specific format, and I think that even something like that, it's very easy for us to just give it to an operational guy that doesn't know to program and tell it, okay, this is what you do. You just map the field in this format, throw it in there, and everything works. Marbach Daniel is asking, could you show us the most efficient way to delete a lot of documents? And this is actually interesting. This is actually interesting because there isn't a very efficient way to delete a lot of indexes. And I need to explain why. So a lot of the things in RavenDB are optimized around the notion that we can use the e-tag to discover what sort of work do we have to do. So for example, we can use, let's say that I indexed up to document 5, and then we added 2 more documents. I don't actually need to keep track of how many additional documents do I need to index. All I care about is that I need to index the documents after document 5. With deletes, the situation is different. Let's imagine that I'm now deleting a document from the database. Deleting a document from the database means that I have to remove it from all of the indexes. In the case of MapReduce indexes, I have to potentially do a reduce or remove the value altogether. Because of that, for every document that we delete, we keep an internal record. That record is the remove from index task, if you care to go into the code base and look at that. And what it basically does, this is an instruction for the indexes to go and remove the presence of that document data in the indexes. And the reason that it takes a lot of time to actually do indexing, to do deletes, is that we have, let's say that you want to delete 5,000 documents, then you're going to have to delete 5,000 documents, insert 5,000 tasks, and then process those 5,000 tasks. And processing those 5,000 tasks may mean that we actually have to do physical deletes in the Lucene index. It may mean that we have to do a reduce. So that's the reason why deletes are relatively slow in RavenDB. By the way, slow still means that you can do tens of thousands of them very, very easily. But this is something that is limited in the way that we're working. So Chris Wayne is asking, any plan to make RavenDB available as an Azure add-in? It looks like there is already one for MongoDB. And yes, we are already working on that. We are probably going to have that in the next few months. We're already working with some of the guys from Azure, and you will have something there in the near future, yes. Matt Johnson, are all the incremental needed for the restore or just the last one? Also, can I encrypt or compress the backups? Well, since the backups are already compressed, there is no real point in compressing them. We don't provide any out-of-the-box facility to compress periodic backups, although if you want to do a pull request for that would be wonderful. And yes, you need all of the incrementals because, well, they're incrementals. That's the way that we actually handle that. We replicate up to a specific point, and then when the next time for replication happens, we'll actually have the time to that's when we have the time to actually replicate everything properly. One thing that you need to be aware of, periodic backups do not replicate deletes. And the reason that they do not replicate deletes is the same reason that I just told you. It's very hard for us to detect that the delete has happened. We already have something like that, a delete detection for when you have replication. We call it tombstone markers. We might do something like that for periodic backups as well. But right now, if you have a document and you have periodic backups and you deleted that and then you restore, that document is still going to be there because we do not keep tracks of delete in this fashion. Okay. So Mark Daniel is asking, I know this topic you don't like, but imagine I have a lot of documents which I need to export into a CSV file. Okay. So you need to, that is an interesting question. Let's see how we do that. Pam, 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 pam. Okay. This is a really, really bad way of doing things. But what I'm doing right now, I'm inserting 10,000 items into Raven. And let's see. So I just did insert 10,000 items into Raven. This gives you two very interesting things to note. First of all, let's see what happens when we start working like this. And as you can see, it just worked. We just replicated, and there hasn't been a lot of time passing. It just happened very, very, very quick. And now let's say that what I want to get out of this is I want to query users. And so let's say that I want the user ID, name, and email, and I don't care for the fonts. Now let's look at this tiny button. And users. And now we can see that we're actually exporting things. But let's see what are we actually exporting. And we are done. And now we can see that we export all of the users out. Okay? If we really wanted to, we could have done an add sort by, etc., and get things out. The basic idea is that we actually added to the studio a really nice way for you to export things out into CSV. The corollary to that is that we also added a really nice way to import from CSV. Well, as long as Excel doesn't hold the file. See that? Now we have import and export from CSV. And that should answer that question. Okay, more things. What if I have to do that in code? You do it in the exact same fashion that we do it. Let me show you how that is done. Where is that? Yeah. So you do that basically, in this case you can ignore the actual code, but what this is actually doing is it fetch and write the next pages. So the basic idea is that we just page through all of the data. I'm not sure that I understand the question. What do you mean, how do you handle paging? In just the way you would handle them otherwise. if we go to this code, and let's say that something like that. So there is the 30 pages, 30 request limit. In this case, I'm going to increase that or use different sessions or something like that. Okay, and that's how it works. You just page through everything. The number of requests per session is a recommendation. This is something that you should be doing. This is not a mandate. The reason this is a recommendation, the reason this is the default, is that this is the valid option for 90% of the cases. But it's not the appropriate value for 100% of the cases. So we say, okay, here is the default. You're free to change that. RavenDB is aiming to give you the right values. It's not aiming to be a straitjacket. And so David Walker is asking, there are issues paging like that if a document is updated while paging. How do you handle that? And the answer is that currently we do not. We have plans for 2.1 to give us so we have plans for 2.1 to give us snapshots. This is what Matt is talking about in here. And 2.1 will basically give you the ability to freeze an index and do stable queries on that. Yes, Joel, you're absolutely correct. I'm missing that. Otherwise, we're basically going to be in an infinite loop. Thank you very much. More questions. Oh, we have someone who raised their hand, I think. Let's see how I do that. Yes. Sean, you're not listening. Who raised their hands? No one. Okay. Guys, more questions. Going once. Going twice. Okay, so this is it for this week. We're going to have another one in about 2 weeks, if I remember correctly. I'm very happy that this thing actually worked. I mean, all of the demos and everything, I was quite nervous about that. And Matt, thank you so much. You have no idea how good it is to get this sort of feedback. Think about the feedback that we usually get in the menus. Oh, I have a problem with X, Y, and Z. So most of our feedback is good, but it's about bad things. So I really love it to talk with you directly, not in the scope of how do we fix this or that problem. Thank you very much, and I will be talking to you in 2 weeks. Bye.